Hello, everybody. I hope you're doing well with online learning and staying safe and healthy. These next few weeks, I'll be making videos like these over the next few sections in Chapter 7. So keep checking back and watching these videos. And today we are going to start with Section 7.4, Properties of Logarithms. So go ahead and pause the video right now if you want to write down these different logarithmic properties. First, we have product rule, which says if we have the logarithm base a of two numbers that are multiplied together, x and y, that equals log base a of x plus log base a of y. The next rule, the quotient rule, is very similar. We have log base a of x divided by y, and that equals log base a of x minus log base a of y. In the power rule, this one's also important. We have log base a of x to the p power. It's raised to some exponent p, and that equals p times log base a of x. So you bring that exponent down and multiply it out front. The fourth one and the last one we're going to look at today is the change of base rule. So we have log base a of x equals log base b of x over log base b of a. So we find a common log, one that will be beneficial, and we divide those two logarithms together. We're not going to look at the equality rule today, so we're going to move on. You've probably seen this before, where if we have a log base b of x and that equals y, we can rewrite it as b to the y equals x. This will be important in simplifying logarithms. So in problem 1, we're going to be simplifying logarithms. We're going to write each expression as single logarithms and simplify them as much as possible. So we have log base 4 of 32 minus log base 4 of 2. If we look up here, we can see that we'll want to use the quotient rule. We have two logs with the same base subtracted by each other. So what we can do is take log base 4 and do 32 divided by 2. We're applying the quotient rule here. And once we do that, we'll get log base 4 of 16. Now, we're not quite done because we want to simplify it as much as possible. And if we look here, we can rewrite this as log base 4 of 4 squared. And we look here, and we have log base 4 of 4 squared. We can use the product rule, or power rule, my bad, and write it out as 2 times log base 4 of 4. Now when we have a logarithm that has the same base as the number right here, so the base and the number are matching, that will just equal 1. So we end up getting 2 times 1, or 2. So I'll break this down more. Log base 4 of 4, we can rewrite it using this, and we'll just say that equals y. So we have 4 to the y equals 4. Now the only number that y can be is 1, and that's why that equals 1. So let's move on to part B. We have 6 log base 2 of x plus 5 log base 2 of y. Now when we have these coefficients out front, we can use the power rule and rewrite it as log base 2 of x to the 6th power plus log base 2 of y to the 5th power. And now we have two logarithms with the same base adding together. So we can use, look up here, the product rule. and we can multiply x to the 6th times y to the 5th. And we can't really simplify this any further, so this is our answer. And that is how we want to simplify logarithm expressions. Now we're going to look at expanding logarithms, so we're going to be going the opposite way. We want to write what is each logarithm expanded. So we have this logarithm, log of 4x over y. Now we can use the quotient rule to expand this, and that quotient rule says log of 4x minus log of y. Now this isn't quite expanded far enough. We can expand it further because we have 4 times x here. So we can use the product rule and look at log of 4 plus log of x minus log of y. And that is expanded as far as we can get it. So if you want to try B on your own, go ahead and pause the video, work on it, and then unpause it, and I'll go through the solution. So we want to expand this logarithm. We have log base 9 of x to the 4th divided by 729. So we use the quotient rule where we can break it apart. Log base 9 of x to the 4th minus log base 9 of 729. So after that, we have the exponent x to the 4th. We can use the power rule and bring that down. So it's 4 times log base 9 of x minus log base 9 of 729. There's one more step. 729 is actually 9 cubed. So we can rewrite this as 4 log base 9 of x minus log base 9 of 9 cubed. And we remember from the first problem that we can rewrite this as 4 log base 9 of x minus 3. Since the base 9 and 9 match, that's just 1, and you bring the 3 down in front. So that's how you expand that logarithm. One more type of problem we're going to look at is using the change of base formula. So as a reminder, I'll scroll back up here, and we look at change of base rule. If we have a logarithm base a of x, that will equal the logarithm base b of x, a different base, divided by logarithm base b of a, which was your original base. And there are a couple methods that we can use to solve this. First, we can find a common base that the two numbers share, so we can get whole numbers and divide them. The second method is just to use a calculator. So let's look at the first method. We want to use a common base. What do 81 and 27 have in common when it comes to exponents? They are both different exponents of 3. So 27 is 3 cubed, and 81 is 3 to the 4th. So we want to use 3 as our new base. So log base 81 of 27, that equals log base 3 of 27 over log base 3 of 81. And if we rewrite those as exponents of 3, we get log base 3 of 3 cubed over log base 3 of 3 to the 4th. Similarly to the last problem, if there's a log base 3 of 3 to some exponent, your answer will be that exponent. So we get 3 over 4, because the exponent here 3 and the exponent here 4. If we were to use a calculator, we would plug in log base 81 of 27 equals, we just use log 27 over log 81, and you will come up with 0.75, or 3/4. So either method works. We'll see in the next problem that method 1 won't work, because 5 and 36 don't share the same base, or don't have a common base. So we'll have to use a calculator. Because 5 and 36, there are no common exponents that you can get using those. So go ahead and plug in your calculator. Log of 36 over log of 5. And you will get approximately 2.23. So this section is all about remembering the properties of those logarithms and applying those properties to these different kinds of questions to simplify, expand, solve, evaluate all of these expressions. So let's scroll down here. Here is your homework. Page 466, numbers 9 through 43 odd. These problems don't take very long, so it won't be too much work. But go ahead and work on those, and we will have a review over 7.1 through 7.4, I believe, and then we'll have an online test. But Mr. Bradick and I will communicate with you about the next steps. All right, so have a good day and be safe and stay healthy.